So today we are talking about having square roots in the denominator. You're actually not allowed to. It's kind of like, you guys know when you write a sentence, the first word is capitalized. If I take out my calculator and I do 5 divided by the square root of 3, I'm going to get a number just fine. But for whatever reason, someone at some point decided we are not allowed to leave irrational numbers in the denominator. Okay? And weird square roots, so square root of 3, square root of 5, square root of 7, ones that don't come out nice, those are irrational numbers. Those numbers that never repeat and go on forever if you turn them into a decimal, right? So, we're not allowed to leave square roots in the denominator. So that's kind of the big, no square roots can be left in denominators. And honestly, I know you're going to hate to hear this, but there's not really any mathematical reason why. I know, so you would think, well, Miss Sabia, then don't teach us this. Why does it matter? It matters because when you go to take the MCAS, when you go to take the SATs, when you go to take the ACTs, none of their answers are going to have radicals in the denominator. So you're going to need to know how to convert. It's called a process. The process is called rationalizing the denominator. So what we're doing is we are taking the denominator and we are getting rid of the irrational part of it. So that's why we are rationalizing the denominator. So I'm going from, so if I look at the example in this problem here, letter A, 5 over the square root of 3. So I'm not allowed to have a square root of 3 in the denominator. Square root of anything. Yes. Yes. Guys, think about it. How do you undo a square root? You square it, right? Now, I can't just square this whole thing and call it a day, right? I can't just take a $5 bill and just square it. Right? I wish I could. I would do it all day long. I can't just take this fraction and square it. It wouldn't be equal to itself anymore. Right? Like if you take a half and you square it, it doesn't come out to be a half anymore, right? What's a half squared? A fourth. And that's totally different. Right? So you can't just go around squaring fractions, but what you can do is I can multiply by 1. Isn't 1/2 times 1 still 1/2? Right? Are you with me? Yeah? Okay. So that's what I basically need to do. I'm going to take this fraction and I'm going to multiply it by 1, but I'm going to disguise it. It's not really going to be a 1. Yes, I'm going to multiply it by the square root of 3 over the square root of 3. And that accomplishes two things at once. First of all, I am multiplying by 1. Isn't square root of 3 over square root of 3 just 1? Yes, but look at the denominator. Now I'm squaring a square root. So I'm allowed to have square roots in the numerator all day long. I'm just not allowed to have them in the denominator. So now if I multiply this through, 5 times root 3 is just 5 root 3. And then my denominator is now just 3. So this is the exact same thing as this. If I put them both in the calculator, they're going to spit out the exact same decimal. Watch, I'll show you. 5 divided by the square root of 3 gets me that decimal right there. You see that? There's 5 divided by the square root of 3. Now, I'll do 5 times the square root of 3 divided by 3. Oh wait, I got to put this whole thing in parentheses. So there's 5 times the square root of 3 divided by 3. You see that? It's the same exact decimal. So those two fractions are equivalent to each other. The difference is this one doesn't have a square root in the denominator anymore. And that's what I need. Okay? So when you go to take the MCAS, there will not be an answered choice that's 5 over the square root of 3. because they are going to rationalize their denominators, and it's going to look like that. Okay? So they're different. You got to be careful. Now, one other thing that you can do to make your life a little bit easier. Let's say I want to take a square root of an entire fraction. Say I want to take the square root of, I don't know, 3 over 18. Actually, no, I don't want to do that one yet. Sorry. So I want to take the square root of 4, let's do 14 over 9. Okay, so the good news about something like this particular one, if I want to take the square root of an entire fraction, I can just break it up and take the square root of the numerator and denominator separately. So this just turns into the square root of 14 over the square root of 9. And then lucky for me, the square root of 9 is just 3. So I get lucky here. I don't have to worry about rationalizing the denominator because it just worked out nice. That won't always happen, but in this case it did. So for the same reason, let's say I had something like, let's say I had them split up and I had something like the square root of 30 over the square root of 5. Well, it works the other way too. I have two separate square roots, but what I could do is I could rewrite it as one big thing, as one big fraction. And now I can just reduce that fraction. Right? Well, what's 30 divided by 5? Just 6. So I just end up with the square root of 6 as my answer, and I'm done. So if you have square roots on top and on bottom, you can simplify what's in there with each other. Yeah?
What if the fraction can simplify to like a thing?
Great question. So let's say I had, let's do square root of 20 over square root of 30. Let's say I had that. Whoa, sorry. There we go. First of all, knowing what we just learned, I can reduce these with each other. So what's 20 over 30 really? Yeah, so I really get the square root of 2 over the square root of 3. Now, too bad for me, this still leaves a square root in the denominator. So now I need to fix it. So how did we just learn we were going to fix this? Multiply by the square root of 3 over the square root of 3. So in my numerator, I get square root of 6. And then in the denominator, what do I get? 3. Is that a good final answer? This right here. Yes! Oh, sorry. It is, and let me tell you why. You cannot reduce something that's in a square root with something that's not. They either have to both be in a square root or both not be in a square root. So for example, if I had something like this, say I had,
C is a good example on the sheet.
yeah, so if you look at C, you cannot reduce that 20 with that 5 because the 20 is not in a square root, but the 5 is. Now what I can do, if I had something like 8 times the square root of 2 over 10 times the square root of, I don't know, 12, let's say. Here's what I can do. I can reduce the 8 and the 10 with each other because they're both not in a square root. I can simplify the 2 and the 12 with each other because they are both in a square root. And then I'll just have to fix my answer. All right? So let's start with the 8 and the 10. I can reduce them both by 2, right? So that becomes 4/5. Okay? 2 and 12 would reduce to be 1/6. It's just that that 1 and that 6 are still under a square root. So this becomes square root of 1, and this becomes square root of 6. Yeah, now lucky for me, what is the square root of 1? Just 1. So right now my numerator is just 4, right? Because 4 times 1 is just 4 over 5 root 6. Now, I can't leave the square root of 6 in the denominator. Here is a very common, and I don't want to say it's a mistake, but it's a make your life harder than it has to be move. lots of times kids will get an answer like this, and then they will think, oh, okay, I'll just multiply by 5 root 6 over 5 root 6. That's not wrong, but you're doing more work than you have to, and you're adding extra stuff to your pile. The 5's not the problem. I can have a 5 in the denominator all day long. It's only the square root of 6 that's a problem. So I don't have to multiply by 5 square root of 6. I just have to multiply by square root of 6. And the denominator will still have its square root go away. So what do I get in the numerator now? 4 square root of 6. And in the denominator, what happens when I multiply these two together?
30.
What?
6.
That, well, oh, 30 is my final answer, right. When I multiply these two together, I get 6, and then 6 times 5 gets me the 30. Is this a good final answer? 4 root 6 over 30. I can reduce the 4 and the 30 because they are both not in a square root. So that becomes 2/15.
What if you have like root 6? That's not going to be a rational number, is it?
What do you mean? You can have a square root in the numerator. It's just the denominator that can't have it. So this is a good final answer. You cannot reduce the 6 and the 15 because the 6 is in the root and the 15's not. Okay, so I'm done. A little bit. Not gonna lie. So if I'm just glancing at this puzzle here, so some of the things you're gonna do to make your life easier, like I'm just drawn to letter M real quick. What are you gonna do first? Yeah, you can reduce the 5 and the 10 because they're both under a square root. So wouldn't that just become 1? So and they're both still under square roots though. So the square root of 1 is just 1. But then I just have to deal with the square root of 2 in the denominator. But that's better than dealing with a square root of 10. And I don't have a square root in the numerator anymore. Not that that matters, but it just makes my life a little bit easier. So if you can, like letter N. Ooh! Letter N, if you simplify first, your life is so easy. You can just look at N and tell me the answer. What is it?
3 square root 3.
Yeah, 3 root 3, right? Because 6 over 2, right? Isn't that just 3 over 1? So I don't even need the 1 anymore. That's the answer is just 3 root 3. And I'm done. Because I don't end up with a square root in the denominator anymore. So always simplify the fraction first and then fix it. Because sometimes you won't be left with a square root in the denominator and you don't have to fix it. Okay? So this is simplifying when you have a monomial over a monomial. I'm going to let you try this and then we're going to come back and try with a binomial in the denominator.
I actually like the choice words.
Oh, I don't know what it is yet. But if you guys could take maybe 10 minutes or 15 minutes or so and finish this side here.